Okay, here's the next problem. We're working on practice problems for Math 55, Unit 3. So this will be the midterm. And this we're solving for x. So x over 9 plus x is equal to 7/18. What we always want to do is try to combine like terms in order to simplify. And so we've got a fraction with x as the numerator and 9 in the denominator. And we're adding that to x. So x over 9 plus x is equal to 7/18. How do we solve this? Well, what's the rule when you add regular fractions? If they don't have the same denominator, what do? So let's rewrite. We have x over 9 plus, and we know that any number divided by 1 is equal to its value. So x over 1 is the same as x, so we can rewrite it that way. Does this make it easier to see how you would add x over 9 plus x over 1? How do we give them the same denominator? We can multiply this by 9 over 9, right? Which is the same as 1. And we end up with x over 9 plus 9x, oops, that's a weird looking 9. 9x over 9, right? So now the denominators are the same, so we can combine them. And so x plus 9x is 10x. 10x over 9 is equal to, well, we kind of went on a journey, 7 over 18. And normally what we do in a case like this, we want to solve for x. We don't want to know what 10x over 9 is. We have to get rid of the fraction here around this. So how would we do that? We have to eliminate the 9. So, anyone have any ideas? How about if we multiply both sides of the equation by 9? So normally when we do that, we can just draw a line through the multiplying 9 and the dividing 9, and that leaves 10x, or you can multiply it out. You get 90x over 9, and then you can divide 90 by 9, and you get 10x, and 9 by 9, and you get 1, and this is equal to 10x. So 10x should be equal to the same thing as 9 times this number, this fraction. So we've got 10x is equal to 9 times 7 is 63 over 18. So can 63 over 18 be reduced? Can it be simplified? We've got an odd number and an even number. Does that matter? We're looking, can you think of the factors of 63 and 18? What's the biggest factor you think they both can be divided by? I'd go with 9. Let's divide both the top and the bottom by 9. Or hang on, maybe we should divide both sides by 10. Let's just isolate x and see what we end up with. I'm going to back that up a little. Let's go back up. Oops, that's far enough. So 63 over 18. So in order to get just x by itself, we're going to, here's purple. We'll divide both sides by 10. And this divided by 10. All right, so this will leave x, but then how do we divide 63 over 18 by 10? In division, fractions and division, we invert and multiply. So this is 63 over 18 is the same as 10 over 1. Or if we multiply, I'm going to move it up here, x should be equal to 63 over 18 times 1 over 10. So x should be equal to 63 over 180. And now we can reduce that fraction. And it has the same 63 is evenly divisible by 9. So let's at least start with 9. Divide this by 9 and divide the bottom by 9. And we'll get 7 over 20. And I don't think that will reduce anymore. 7 and 20 are mutually prime or coprime. So x is equal to 7/20, and that would be the answer you put in this little box. So it's kind of tricky here to have x in the numerator, but you just have to remember all your rules for fractions. If you want to add a whole number x to a fractional x, just follow the same rules. You need to have a denominator that matches. And that's true in any addition or subtraction ever in math. You always have to have something in common. So we put x on a 1, which is equal to x, and then we multiplied it by 9 over 9. Okay, so if you have any questions, come see me or set up a Zoom session. I'd be happy to help.